Hi, my topic is aided inertial navigation with geometric features, the observability analysis. And my name is Yulin Yang from University of Delaware. We want to study the aided ends. The aided ends contains an inertial measurement unit, IMU, and an aiding sensor. This system will explore the environments along this trajectory. During the exploration, it will measure the point, line, and plane features. We want to study the observability properties of this kind of system. The observability matrix for linear ends is Mx, which contains two parts. One is the measurement Jacobian, the other is the Steve's transition matrix. And we see that N is the unobservable space if Mxn equals 0. We first start with aided ends with point features. The continuous time nonlinear ends, aided by genetic range or bearing measurements with point features, have 4 unobservable directions. The 4 unobservable directions contain two parts. One direction leads to the globe yaw. The other 3 directions lead to the position of the sensor. If the system can get global measurements, the unobservable direction will be less. For example, if the system can get a global position x measurement, then the global position x and the global yaw will become observable. We also identified degenerate case when the system will have additional unobservable directions. For example, if the system have only pure translation, then the global orientation will become unobservable. If the system have pure rotation, moving toward a feature, or constant acceleration, then the system scale will become unobservable. For aided ends with line features, if only one line feature is used, there will be 5 unobservable directions. The additional unobservable direction relates to the line direction. If multiple unpaired lines are used, there will be 4 unobservable directions. For aided ends with plane features, if only one plane feature is used, there will be 6 unobservable directions. The additional 2 unobservable directions relates to the plane motion perpendicular to the normal direction of the plane. If multiple planes are used, there will be 4 or 5 unobservable directions. In conclusion, we did the observability analysis for ends aided by genetic range or bearing measurements with points, lines, and planes. We also studied the effect of global measurements on system observability and identified 4 degenerate motions. We proved that for linear aided ends, there are at least 5 unobservable directions for a single line and 4 for multiple unpaired lines. We also proved that for linear aided ends, there are at least 6 unobservable directions for a single plane, 5 for 2 unpaired planes, and 4 for multiple planes with unpaired intersections.